let me recap what we had done. We have already seen what are the various web applications we have seen so far, and what are their various side effects, what are their various attacks possible on those web applications, right? We have already seen what exactly is OWASP top 10 and how crucial they are to any particular organization when it comes to securing or safeguarding your web applications. There were top 10 attacks. Apart from those 10 attacks, there are n number of attacks possible, but those are the most crucial top 10 attacks which have been discovered so far. Okay, so that's all about the previous lecture. Let's begin with today's agenda. That is, we are going to learn what exactly are cookies. We had started off with cookies in the last lecture. I had just given the structure of what exactly the topics are left. So we are going to start with cookies, go into the technical depth of what exactly is cookie, what exactly the values are stored inside a cookie. And after completing that, we are going to move towards the most important topic for today, that is secured socket layer or SSL. You already know what is an SSL. We have seen in cryptography and system security. Today, we are going to learn it from a different perspective, from a different technical aspect, how they are useful to any organization, and why we should go for SSL if you are having your own website or a web server, right? So let's move on with this particular first topic, that is a cookie. What exactly is a cookie? Okay, so you know what exactly is the theoretical aspect of a cookie. I'm just going to take 2 or 3 minutes to discuss what exactly is a cookie, and then I will show you how exactly cookies are created, where are they created, where are they stored, and what are their applications. Okay, so let's have a look what exactly is a cookie. Cookies are basically very small sized files. They are text files that are stored automatically whenever a website which is having cookies is visited. For example, if I visit a website, for example, Amazon, Flipkart, or any other e-commerce website, what exactly happens is that particular website may automatically store your cookies, or it may ask for your permission. You might have seen some websites ask you whether you would like to allow or block cookies. Okay, so some websites might even ask your permission to store your cookie values beforehand, but all the e-commerce websites that I know automatically store your cookies. For example, whenever you visit Amazon, it might give you a recommendation, it might give you something. For example, if you have bought a product recently, then all the products which are related to that particular product may be shown to you as a suggestion. For example, if I have bought a mobile phone recently, then it might give me a suggestion for a Bluetooth headset. So how does it predict such a thing? It predicts with the use of cookies. There is no machine learning or AI involved over here. Otherwise, the website maintenance will become really costly. Over here, what they do is they simply make use of a very simple technique, very simple concept, which is called as a cookie. What cookies do is they are basically very small files that are that the websites leave on your computer's browsers. So whenever you are using a browser, for example, if I'm using Google Chrome right now, it is continuously keeping track of all the cookies. For example, if I visited a website, the next time whenever I visit that website, it will first of all load quickly because of the cache, and second, whatever activities I have performed in the past on that particular website will automatically be highlighted. For example, the shopping carts. Whenever I visit a particular website, again I will take example of Amazon. If I have logged in, if I remain logged in, what exactly happens is it fetches the cookie value stored in my browser, Google Chrome, and then tells me that so and so thing is present in your shopping cart. This is happening with the help of a cookie. You're getting what I'm trying to say? If any doubt so far, kindly let me know.
No, sir.
Okay. If my voice is cracking in between, kindly let me know. I can turn off the video if required. Okay, so basically cookies are those small files that the website leave on your computer browsers. The cookies allow the websites to remember the user's behavior. We have discussed it just now. Every time the user logs onto that particular website, the browser will send the cookies back to the server. This is what exactly is happening. For example, if I'm opening Amazon.com, my web client or my browser is trying to create a connection or is trying to create a communication with the Amazon's browser or sorry, Amazon's web server, right? So what exactly happens is the cookie stored on my browser will automatically be sent to Amazon's web server as soon as I visit Amazon.com. So what happens exactly before even the connection is complete, the cookies have already reached the web server's location, because of which whenever I open Amazon.com, it immediately gives me some suggestion. Go for this based upon your previous experience. We are highlighting so and so thing for you to buy. Right? This is what happens. This is again a very well planned business strategy. Uh, you will learn in DWM, you might have learned, or you will learn in DWM, data warehousing and mining, about the a priori algorithm, if you remember. If you have done it, very good. Market basket analysis. If I place something, for example, if I'm going to buy a loaf of bread, just adjacent to it, there you might encounter butter or jam or something else. So all the things which are related with each other are kept together. So if I buy something, I might buy the related item also. Similarly, if I'm going for a mobile phone, it will notify me, it will recommend me go for a good branded earphone also. So this is how companies work. This is how e-commerce organizations work, right? So how does a cookie basically act? How does a cookie work? What is the basic component of a cookie? Okay, have a look over here. Basically, this is how a cookie looks like. A cookie consists of these following components: name, value, and some attributes. Okay, so what are those attributes and what is the actual organization of a cookie? How does it look? Let's have a look at that. This is how a cookie is created. Over here, have a look. A web server specifies a cookie to be stored, right, by sending an HTTP header. This is what I had just now discussed. Whenever I visit a website, an HTTP header request will be sent to the web server and the corresponding cookie value will be set. If it is already set, the actual cookie value will be fetched from the browser and sent to the server. So what exactly a cookie is made up of? The cookie is made up of these three parameters. The very first thing over here is the cookie name, okay, or the value we can call as. Then few attributes. The attributes are nothing but the expiry date of that cookie, okay, the domain which I'm visiting, for example, Amazon.com, and the path of the cookie, where it is exactly stored, right? This entire thing is what is present inside a cookie. Now, let me give an example over here. This is how a cookie is set. Okay, I'm giving the name of the cookie as new value, okay, and then it is expiring at so and so date. So I will give you the expiry date also for that cookie. The path so and so. The path is nothing but, if I enter a slash over here, it means the root directory. So whatever is the root directory of that web application, that is example.org, that is the by default path of this cookie. So whenever I'm visiting example.org, any particular subdomain of this particular website, example.org, will automatically create a cookie and send it to the web browser. We got the last part, the path, that is a slash. The slash is nothing but the root directory. So whenever I'm visiting this domain example.org, automatically a cookie will be created. Clear with this? This is how cookies are set and sent to the web server. Clear with this? Kindly let me know. If you're clear with this, then I can move ahead. So kindly acknowledge and reciprocate. Yes, okay. Okay, clear. So let's move ahead with the next explanation. Okay. So basically, the first part of the header, this is nothing but the header. This particular thing you saw over here is a header. Okay. What we can do is, instead of just writing name equal to value, okay, we can simply write value itself. For example, over here, you can see that I have not mentioned name equal to value. This is just the syntax, but if you write only value, then also it is correct. Instead of this name equal to value, if I write only new value over here, the new value is nothing but the name of that cookie. Then also it's valid. That is what it is being written over here, that whenever a cookie is present and the optional rules allow, the cookie value is sent to the server with each subsequent request. Okay. Over here, the most common usage is to specify a cookie value as name equal to value. But if you write only value, then also it is correct. That is what exactly I'm trying to say. If you are not writing it like this, okay, just give me a second. Yeah, if you're not writing it like this, for example, I want to set a cookie as my name. So if I'm not writing it like this and I'm writing it only like this, then also it is correct because I'm simply mentioning the name of that cookie. So this particular variable name is optional. You can write it to make a good impression, basically to improve the viewability or readability of that cookie value, or you can simply write the name of that cookie directly. It doesn't matter, right? So this is how a cookie is created. It is nothing but a text file. You don't need to create it. It basically gets created automatically whenever a browser visits a website. It basically is done from the backend. The designers create the templates of that cookie, so it automatically gets created. No interference from your side. Okay. So there might be some restrictions on the cookies also. What can be the restrictions? Have a look over here. Any idea about the restrictions? Have you gone through it? Have you gone through the restrictions of
Allow or block. Allow or block.
what? And kindly elaborate, please. Allow or block. Okay, that is not a restriction. Basically, I'm just saying कि cookies का खुद का क्या restriction होगा? What are the restrictions of cookies? I'm not talking about the web site from where the cookie is being accessed or not. Intrinsically, are the cookies having some restrictions? That is what I'm asking.
उसकी मेमोरी या साइज का रह सकता है सर। एंड उसका जैसा आपने बोला वो टाइम लिमिट होता है, उसका भी वो एक रिस्ट्रिक्शन हो सकता है कि एक्सपायर इतने टाइम में हो जाएगा।
Correct. Okay. They are active for a limited period of time. Correct. So basically, cookie has an expiry date. Okay. Is my voice cracking because the voice I am receiving is cracking a lot? No,
That's
no.
pretty
Okay.
perfect, sir. Yes, sir.
Okay, okay. Thank you so much. So, what I actually wanted to say is cookies basically, first of all, have some expiry time, right? So, after some point of time, the cookies will expire automatically. Second, the size limit. Over here, the cookies have a size limit, maximum size limit of 4 KB. Now, you know that 4 KB is very small, right? But as you know, it's a text file, so it won't occupy much space. So the first limitation is the size of the cookie value is 4 KB. At some point of time, you may run out of space. This might be a restriction in the future. So we can talk about it as one of the restrictions. Secondly, the time, obviously the expiry date, it is again the second restriction. And third restriction is some browsers allow a fixed number of cookies from a particular domain. For example, initially there was a restriction of 20 cookies only per domain. So if I'm visiting amazon.com, it could only store 20 cookies per domain, that is amazon.com, for a particular browser I'm talking about. Just imagine if you're having that computer system installed on a cyber cafe. N number of people may visit your cyber cafe. So it might be possible that many of those people are having different accounts on Amazon. Even if 20 or 30 people visit that particular website from your cyber cafe, the browser will reject the remaining cookies because one cookie is stored for each user, right? So if there are multiple users visiting that particular application from your computer system, then it might run out of cookies. So initially the limit was 20 cookies per domain, which was then increased, and Internet Explorer came up with 50 cookies later on. Okay, IE7. Then IE8 again followed that with 50 cookies. Now Google Chrome is having more than 50 cookies. Okay, over here I have written it somewhere. I will show it to you. Google Chrome and Safari. Yeah, correct over here. Safari and Chrome have no limits. They have increased the limits, and that is why Chrome is very popular, and Safari is also popular in iOS, Mac, etc. So that is why people are more inclined towards Chrome. First of all, it is very fast, and second, it doesn't have any limitations on cookies. So you can use commercially these browsers for setting up your, for example, I have given the example of a cyber cafe or any other business organization. Cool. So these are the basic limitations of a cookie. So I have again written it over here. Okay, so per domain over here, don't get confused. I've written it may only store 300 cookies as in the total number of cookies, but per domain only 20 cookies. Okay, clear with this? This is important. Per domain, only 20 cookies, and at the max 300 cookies per browser. This was the earlier restriction. Chrome has removed this restriction. So the first and third restriction is not applicable for Chrome, but for the other browsers, they are applicable, right? So you may encounter that whenever you are deleting your history, your cache, your cookies in Chrome, it takes a longer amount of time. Why so? Because in Chrome, there is no limit on the number of cookies to be set. So as a result, more number of cookies are stored on the browser. So it might take a little longer time to delete all your cache and the cookie values from your Chrome browser. Why so? Because of the same thing, it doesn't have any restriction on the number of cookies that can be stored on the browser. Here with this, any further explanation required on cookies? What
So,
exactly are cookies and how do they?
sir,
Yes.
why do the other browsers have restriction on cookies? मतलब हाँ थोड़ा सा space occupy करता है, loading time का थोड़ा ज़्यादा है, but why are
Hmm.
the restrictions applicable over there?
Basically, if you see that they are doing it for the security purpose, and Google Chrome, as you all know, is pretty much secured as compared to Internet Explorer. If I'm giving the differences, if I'm trying to give you the difference, I would say that Chrome is much more secure as compared to IE or Mozilla Firefox. That is why they are basically relying on their intrinsic security features and not relying on the intrinsic, what you can say, vulnerabilities which may arise out of cookies. So that is why they are not restricting the cookie values. They are trusting their browsers capabilities, their limitations, such that if in case anything happens, they can get rid of that cookie value immediately and dispose of that security threat. That is why earlier browsers are still using 20 cookies per domain. Otherwise क्या होगा, उनका जो कैश का साइज है वो फिलअप होता रहेगा बहुत जल्दी. Google Chrome has a much longer buffer size as compared to IE or Mozilla Firefox. Firefox also has 50 cookies. Initially, it was also having 20 cookies. Now they have increased it. So one of the main concerns is security, and second is the cache size, because ultimately cookies are going to be stored in cache only, right? And as we know that Chrome has a very lightweight application, it is also suitable for mobile phones also, right? That's why they are depending on their intrinsic functionalities. It may backfire also in the future, we never know. But at this point of time, it is pretty good, right?
Yes, sir, understood.
Correct.
Thank you.
Welcome. Correct. Yeah, Rishikesh has written Google Chrome is connected to Google account, so it uses the cookie. Correct, because Google itself is a huge multinational firm, right? Multinational organization. They make use of that cookie values. As n number of times I have explained that uh, data is the new oil, so Google makes use of that data with or without your permission, right? So they can make use of that data for their recommendation engines. They can make use of, like similarly, yesterday I came to know about Facebook's new off Facebook activity, something like that. Okay, so basically, even if you're not using Facebook, your activity is getting tracked. So I will tell you more about that in later sections of either today or in the next lecture. Okay, I will do some research on that and come back to it. So basically, the main intention is the more data you have, the more recommendation will be accurate, right? That is why Google is allowing cookies to be stored on their browser, and they are making use of those cookies for marketing purpose, right? I hope it is clear. Okay, so the first topic, it comes for 10 marks. What exactly is a cookie? And you can write all these points. The very first thing is how, what exactly is a cookie, define a cookie, then how a cookie is created. I will give this workbook, okay, in Google Chrome. Then what is the structure of a cookie, and then followed by the restrictions of a cookie, limitations or restrictions of a cookie. All these for 10 marks. Clear? So can we move ahead with secure socket layer? That is a very lengthy topic. So I'm
Yes,
not
sir.
sure if you, yeah. Okay, thank you. So let's start with secured socket layer, SSL. Before starting with SSL, kindly let me know what exactly you know about SSL.
Sir, it actually transfers data over the internet in an encrypted format, which is nearly impossible to decrypt. It is now considered to be a bit depreciated, but it is still the data integrity over there is still the maximum, so it is still being used.
Okay. What I can say is it is not deprecated yet. It has been replaced by TLS. That is transport.
Exactly, it is actually replaced by TLS, but due to some issues, they were saying that it is considered to be depreciated.
Okay. So let's see what exactly is SSL. Very well explained. SSL is basically used to encrypt your data. It provides a secure connection, very well written by Jinal, between web browsers and web servers. Okay. So whenever you're communicating with a web server, you are making use of a web browser, right? So if I want to make sure that the data which is flowing between the client and the server, if I want to make that secure, I would need some kind of encryption. As you all know, encryption adds a layer of masking in between the 2 points, that is a client and server. So if I don't want my data to travel in plain text, I would make sure that the data is properly encrypted. Either I will make use of AES, the most commonly used application for encryption, or I will make use of RSA. I can make use of any other symmetric or asymmetric encryption techniques. So basically, SSL makes use of 128-bit or 256-bit of encryption of AES. Okay, I would not go into the details of which algorithm they are using. Basically, I'm going to explain you what exactly SSL is and how it works using its protocols. Okay, correct. It is commonly used to secure servers to browser transactions. Correct. Basically, if you are doing some transaction, with a transaction, I don't always mean financial transactions. Transactions can also be in terms of authentications. If you're logging into if you're logging into a Gmail account, that is also a transaction. You are sending your data and receiving something back from the server. That is also a transaction. So whenever you want your transaction to be secure, you should make sure that the web server with which you're communicating is properly making use of some secured socket. That secure socket is nothing but uh, like a tunnel using which the data can securely communicate between point A and point B. Right? So let's talk about what exactly is secure socket layer. We have seen it in detail in CSL, CSS, uh, okay, in your last subject, but we are now going to look at it from a different perspective. So let me give you the entire brief of what exactly we are going to learn today. So these are the things which we are going to learn today. I will obviously zoom it up, don't worry. Okay, so just have a look how vast SSL is, and we have not even done 50% of it in your previous semester. So this is what we are going to learn starting from today. I hope it is completed. Otherwise, we can extend it in the next lecture. No issues with that. The intention is that you should learn this thoroughly. You are going to use it sometime or the other in future. Okay, so let's have a look the small brief history of SSL. Just read it once. I will just go through the questions being asked in the comment section. Correct. Gunjan has written that as it has not been updated since the last 20 years. Yeah, more than 20 years. In fact, 24 years. So it has been replaced by TLS. Have a look at this history. The very first version of SSL was originally developed by Netscape. You might have used Netscape browser. Netscape browser was having an inbuilt SSL. I have used Netscape. I don't know you have used it or not. It was very popular in around 2000 or 2010 in that particular decade. So Netscape browser came very popular as a competitor to your Opera browser, Firefox, and Chrome browser. Okay, so Netscape had an inbuilt SSL, which was then released in the public domain. In 1994, SSL came as the first version. Then version 2 with few changes, minor changes came into existence in 1995. And the final version that we are using right now came in 1996 as very well explained by Gunjan. It has not been updated since then. The last update was made in 1996, and that is the main reason it is now being replaced with TLS. It is also called something like this SSL/TLS because TLS is entirely based on the concepts of SSL. Only the algorithms are differing in case of TLS. Otherwise, the entire structure is same. Okay, as we know, data encryption standard. Then came double DES. Then came triple DES. Triple DES is again making use of single DES only, right? Similar kind of a thing happens over here. TLS is also making use of all the algorithms, all the applications of SSL, but with more advanced set of algorithms. Correct? SSL was initially making use of 128-bit encryption. Now it has moved to 256, and the same is being used by TLS. Clear? So we are going to discuss about SSL. Okay, so this is the entire history of SSL, very short history. The combination of SSL with any particular protocols is known as HTTPS. For example, if I'm making use of SSL with HTTP, it is termed as HTTPS. So whenever you visit a website, if you see that padlock symbol, green padlock symbol on the top left or on the top right corner of the web browser, it is nothing but it is encrypted using some kind of SSL encryption. Okay, right now, okay, let me show my screen. One second. Okay, now is my browser visible right now?
No, sir.
Is it visible?
अब हुआ
Now
sir.
check kindly. Huh. So as you can see over here on this top over here, that is the SSL symbol. So if you click on it, you can learn more. If you click on learn more, you come to know that this particular website or this particular web server is encrypted using SSL. This particular padlock symbol is more than enough. It signifies that your communication is secure. If you click on this drop down, it is mentioning that information you send or get through this site is private. Okay. In some cases, you might see that whenever you visit a website, it tells you that this particular website is not secure. Proceed if you want, but that might not be secure. So that is what happens if you are not having SSL installed on your website or on your web server. If I zoom it up, you can see that what a security certificate is. When you go to a site that uses HTTPS, the website's server uses a certificate. We'll see what is that certificate in today's lecture, which can be used to prove the website's identity to the browsers like Chrome, Mozilla, etc. So basically, whenever you are using a browser and you are connecting to a particular site, a certificate will be sent to the browser. The browser can then verify with the validity of that certificate, who has issued that certificate, who has issued that certificate.
सर वॉइस कट हो रहा है.
Okay, one second. सबके लिए हो रहा है कि सिर्फ एक को ही ऐसा आ रहा है? काइंडली लेट मी नो.
नहीं सर बीच में अटका था अभी वापस नॉर्मल हो गया.
ओके ओके, नेटवर्क इशू होगा. नाउ इट्स फाइन.
यस सर.
एक सेकंड रुको, मैं कैमरा बंद कर देता हूँ. Okay. So basically, what I was saying is, whenever a browser contacts a particular web server, a certificate is sent to the browser. For example, Chrome in this case. Then Chrome will check the authentication or the actual credentials of that particular certificate. If it is 100% sure, if it is 100% satisfied with the authentication, authenticity, or very integrity of that certificate, then only Chrome will allow you to connect to that web server without any issues. Otherwise, it will tell you that that particular website is not secure. Its certificates updated from time to time, so we can directly use this website because I'm right now using Google Classroom. So it is again using authentication auth 0 if you remember, single sign on. So whenever I log into Google, it is automatically authenticating myself also, and it is also authenticating Google to me, right? So this is what happens if you are having SSL present. Okay, so now let me get back to my whiteboard. Okay, so we were talking about SSL. So right now we are just going to start with the actual process of SSL. Is the diagram visible?
Yes sir.
Okay, have a look. On the left hand side, we are having no encryption at all. Then what happens if any particular website is visited? This is basically a, one second, just give me. This is basically a website, and this is the client. Okay. So the client is willing to access that website. What happens? The data, whichever is traveling through the internet, obviously, internet is the most insecure medium of communication. That data can be read by any attacker. Eavesdropping can happen, data theft can happen, and message forgery can take place. That is possible when you are not using or not making use of HTTPS. That is, it is making use of port number 80, which is not secure. Okay. On the right hand side, we are having a setup where you can see that we have shown cross marks. Why so? Because now you can see that the internet is padlocked, or I can say that the internet is now secure, which cannot be accessed without proper credentials. So right now, message forgery, eavesdropping, and data theft is very nearly impossible. I can say 99% impossible. Obviously, you can't say that this particular system is 100% secure or that system is 100% secure. You may never know when an attack may take place. So that is why I am saying that it is nearly impossible, not 100% impossible, to attack any secured medium. Clear with this? This is what exactly happens when you make use of HTTPS or secured SSL connection. Clear with this? Yes.
Yes, sir.
Okay. So next topic is the salient points or the distinguishing points of SSL. SSL basically is not an application layer protocol, neither it is a transport layer protocol. Now you might be aware of what is application layer, transport layer. You have done in ISO, OSI, TCP/IP models and computer networks, right? So I'm not going into detail of those topics. I'm simply highlighting that SSL sits in between application and transport layer, right? It is not a transport layer protocol, neither an application layer protocol. It is present in between the application and transport layer. What is the advantage of that? Any idea? Kindly let me know.
दोनों के सर्विसेज सर यूज कर सकता है इजीली, मतलब यूजुअली
Correct.
ओएसआई मॉडल में लोअर या अपर का ही शायद से यूज कर सकते हैं, इसके अंदर वो बीच में है तो दोनों का यूज कर सकता है.
Okay, correct. Usage of both. So if I am saying that it is present in between transport and application layer, what exactly happens is it makes use of the transport layer protocols to provide security to the application layer protocols. You're getting it? So basically, I am making use of the transport layer protocol to make use of all the application layer protocol. So over here, SMTP is, for example, this is just a example I'm giving. I can use SMTP with SSL. Similarly, I can use IMAP with SSL, POP3 with SSL. Why so? Because now I am making use of both the protocol layers. I am making use of transport layer also, as well as application layer also. So if I'm present in between both the layers, I can get best of both the worlds, right? This is what is happening over here. SSL can use different services of these two different layers to protect the applications belonging to both the layers. Clear? So right now I can say that for HTTP, basically port number 80 is used, but if I want to make it secure with HTTPS, port number 443 is being used. You already are aware of it, right? Similarly, SMTP, simple mail transfer protocol, can be secured with SSL, and that is known as SMTPS. Similarly, IMAP can be secured with SSL, and that is known as IMAP secured, IMAP S. Okay, Internet Message Access Protocol. And then comes POP3, Post Office Protocol, which is basically used to deliver your message. IMAP is used to receive your message. POP3 is used to send your message, if you remember that. Okay, so don't get confused between IMAP and POP3. POP3 is to send your message. Post Office Protocol, you go to the post office to send your letters. Think it analogous to that. POP3 is basically used to send your letters or send your emails, whereas the messages can be retrieved using Internet Message Access Protocol, IMAP, right? So these can be secured using SSL, and those are known as POP3S, IMAP-S, and obviously SMTP is known as SMTP-S. Clear with this? So these are the main distinguishing features of SSL. Now, if this is clear, I can start with the technical aspects of SSL. Kindly let me know if this is clear. Today we are having very less attendance, even below 80. Okay, that is very poor.
सर जब नॉर्मली फोन में या कहीं पे भी वो SMTP इसका मेंशन होता है, इट इज नेवर SMTP-S और POP3S, तो मतलब फिर वो हमारे फोन्स में या हमारे डिवाइसेस में, मतलब लैपटॉप्स में भी वो सिक्योर हुआ कि नहीं हुआ, क्योंकि वी डोंट गेट एक्सेस टू इट एज सच.
See, देखो अगर आप if you are using this HTTPS and if you are entering a website using HTTPS, then whatever protocols you are using inside that application will be automatically secured using SSL. So for example, if you are visiting a website which is already secured using SSL, that is you are already using HTTPS. So once you authenticate yourself to that entry point using HTTPS, then whichever feature you are using of that particular website, for example, Gmail, if you are using Gmail, that is already secured using POP3S, IMAP-S, and SMTP-S in total. So the entry point should be secured using HTTPS. If it is secured, then you don't need these applications separately. Otherwise, if your entry point itself is not secured using HTTPS, then you have to add applications, for example, SMTPS separately, IMAP-S separately, and POP3S separately for securing your communication. Clear?
Yes, understood. Thank you.
So let's begin with this technical architecture of SSL. This is how SSL architecture looks like. Okay. Very first thing is this is the header format, or the what you can see the protocol structure. These are the protocols which are being used by SSL. The first is, you all are aware of it, the SSL handshake protocol. You might have heard about the TCP handshaking protocol. You are aware of it. There is this SSL handshake protocol also involved. We'll see all of these in detail. SSL handshake protocol is nothing but the connection establishment. Once your SSL handshaking is done, just imagine you are meeting a person for the very first time. Formally, you greet that person, you shake hands with them, and then you actually start beginning with your communication, or your conversation. The same thing happens over here. Okay, Harsh, TCP handshaking was a three-way handshaking. This is not similar to that. It is totally different. We're going to learn something different over here. This is SSL handshaking protocol, which is nothing but the connection establishment between the client and the server. The next step is the SSL change cipher specification protocol. Now what happens is the client may be having some set of cipher algorithms present at his or her side, and the server may be having a different set of ciphers. For example, I am having DES, and the server might be having AES. So there is a totally complete mismatch between the application algorithms which are being used at my site and the server's site. So there has to be some sort of understanding between the client and the server. For example, if I'm having DES, I would let the server know that मेरे पास सिर्फ DES है, उसके अलावा मेरे पास कुछ नहीं है. Then the server will also tell the client that I'm having so and so applications with me. Now it's up to you. Choose one of the applications, one of the ciphers which I'm having. Both of them will basically send a list. For example, I am having DES, AS128. The server might be having AS256 and DES. So the common algorithm which is present in both the lists will be selected randomly or arbitrarily, and that particular cipher will be used to encrypt the entire session. Got what I'm trying to say? Both of them might be having different set of ciphers, so they have to come to a understanding that this particular cipher will be used. Otherwise क्या होगा, मैं दूसरा कुछ cipher use करूंगा, server कुछ दूसरा cipher use करेगा, and the keys won't match. Correct? समझा ये सबको? Kindly let me know. Then we can proceed ahead. Yeah, they have to come to a common ground. Correct. You understood what I tried to say? Only 2 or 3 people, 4 people maximum are reciprocating. Otherwise, rest are all just saying mum. Kindly involve in this lecture. Okay. Okay. Thank you so much. Okay. So now let's move ahead. The next thing, which is alert protocol. Now, what exactly is alert protocol? Once the communication begins, okay, the SSL communication once begins, we might face some issues. For example, some connection issue, or some what you can say, some fatal error may occur at some point of time. So at those instances, both the client and the server should be able to alert each other that so and so communication link has broken, or some attack might be happening, and you need to alert the other party that so and so attack is happening. So to cater to that particular situation, this particular pointer is used, alert protocol, that will be used to alert whether the communication is happening properly or not. Okay. Next up, HTTP. This is basically used for transportation. SSL cannot be used all alone. It needs some kind of protocol which will actually transport the message from one end to the other end. For that purpose, we are making use of HTTP. We are securing this HTTP, and then only it becomes HTTPS. For example, if you're talking about emails, this HTTP can be replaced by IMAP. Understood? So basically, which protocol we are trying to secure, that protocol comes over here, right? Next up is SSL record protocol. Now, so far we have seen that SSL handshaking protocol is basically establishment of connection between the client and the server. But somehow the messages need to be transported using the HTTP. For that purpose, this particular protocol, that is SSL record protocol, is used. SSL record protocol is nothing but it is similar to a fragmentation concept. If you remember, data link layer, transport layer, they all have their own units, datagrams, fragments, frames, etc. If you remember, packet datagram unit, okay, datagram, data frames, similar to that. The entire message is broken down into multiple frames, and each of these frames are separately encrypted and then sent to the server. That is what is done with the help of this SSL record protocol. Clear? And all of this works on top of TCP and IP to make the actual communication take place. Clear? So this entire structure is of SSL architecture, SSL architecture. Clear with this? Clear with this so far? These are the two main protocols which we are going to learn, the handshake protocol and the record layer protocol. Clear? These are the two main protocols apart from whatever is mentioned over here. Clear? So let's begin with the TCP handshake protocol. First, have a look at this diagram and then we can move ahead. It is not similar to what we have seen in TCP handshake. It's totally different. It consists of these four phases. The very first phase is what we call as establish security capabilities. In this first phase, the client will first send a hello message. The server will reciprocate it with the server hello. I'm going to go in detail of all these phases one by one. Just giving you a recap of, just giving you a basic preview of what exactly this entire diagram is all about. The first phase is all about establishing the security capabilities. I am so and so, I have so and so features with me, I want to secure this application. So kindly provide me these applications. This is what the client requests from the server. The phase two is all about exchanging all the authentication messages from the server. The server will send his or her authentication messages or keys in phase two. In phase three, the same will be done by the client. And finally, after all the authentication exchanges have taken place, final phase will be all about the actual commit phase or the finish phase. In the first three phases, we will come to know whether the client is genuine or not. Similarly, we will come to know whether the server is genuine or not. And if at all, after getting satisfied by all the three phase results, we can finally conclude that now I can begin with the actual process of SSL encryption. So you can say that this entire thing is present inside this small little block over here. All of this happens within fractions of seconds. You click on a particular website, it opens up within few seconds, within few milliseconds, the entire process has already taken place at the backend. This is what happens. This is just one of those cycles, one of those protocols, which is SSL handshake protocol. Okay, so now we'll go in detail what exactly is this handshake protocol. Okay, we are going to start with the phase number one. If you wish, you can write the only write the headers or write the main points which I'm trying to explain. Okay, very first thing is phase one. In phase one, what happens is a logical connection is established between the client and the server. Okay, so it makes use of some messages. Negotiations take place between the client and server. And what sort of negotiations take place? Let's have a look at that. Very first thing is the client will send a hello message. Now, what exactly is the client hello all about? I'm writing on this right hand side. Let me change it here. The client hello basically consists of these messages. Very first is version. Now, what is this version? The version is nothing but, as I had already explained, SSL has three versions, right? So whichever version the client is using, the client needs to mention that, for example, I'm using version 3. So I would be mentioning that in this format, version 3 or whatever format, right? So basically, the client has to mention the highest SSL version that is supported by the client. Can anyone tell me what are we actually discussing right now so that we come to a same page? What exactly are we discussing right now in phase one?
सर बेसिकली क्लाइंट एंड सर्वर एक दूसरे के साथ कैसे मतलब पहले अक्वेंट होते हैं उसके बाद कैसे एक दूसरे के साथ कनेक्ट होते हैं वो पार्ट
करेक्ट सो वही फर्स्ट पार्ट है फेज वन बेसिकली दोनों आपस में एक दूसरे के साथ कम्युनिकेट करने से पहले दे हैव टू नो अबाउट ईच अदर that's what we call as established security capabilities, correct kind of planning setup. Yeah, we can say client server response. Yeah, correct answers. So basically चेक कर रहा हूँ कि क्लाइंट एक्चुअली एग्जिस्ट करता है, सर्वर एक्चुअली एग्जिस्ट करता है या नहीं इन द वेरी फर्स्ट स्टेज. Client will tell about him or her to the server, and the same thing the server will do to the client. Okay, so very first thing in client hello is all about the version, and second is some random data. Okay, let me tell you what exactly is this random data. This random data basically consists of two things. This is a very deep concept. Okay, so pay attention properly. Random data is all about two values. First thing is a 32-bit timestamp. We have not covered SSL in such detail in CSS. That is what we're going to do now. And a 28 bytes of random data. Okay. Now tell me what exactly is the motive of using such a thing. Timestamp तो आपको समझ गया होगा 32-bit timestamp just to make sure the timing at which the client initiates that session is recorded. Okay, that is the timestamp. What about the 28 bytes of random data? Why are we using that?
यूनिकली आइडेंटिफाई करने क्योंकि वो 28 बाइट का रैंडम डेटा हर यूजर का सेम नहीं होगा मतलब हर क्लाइंट का सेम नहीं होगा
करेक्ट just to make sure that बाद में कभी अगर मुझे चेक करना हो I can check the actual authenticity of that user. This is nothing but if you remember we had learned a concept called as nonce. याद है किसी को? You remember
Can you repeat it, sir?
We had learned about a concept called as nonce. लिखा है मैंने बोर्ड पे. You remember what exactly was nonce? Any one of you? It has it is basically an abbreviation. Random number, okay. We can say that it is a number which can be used only once. I told you, number to be used only once. That is why nonce. Clear? So basically, this random data is nothing but a nonce or a random number which can be generated only once. You won't get the same number again and again. Clear? So this is just the second aspect of client hello. What is present apart from these? Apart from these, you also have one session ID. Okay, the session ID is basically, again, it's of two types. It's very vast, so we have to repeat it n number of times. Okay, Harsh, what is your question? Kindly let me know what is your question, or I can move ahead. The session ID. First of all, session ID is of two types: either a non-zero number or a zero value. Okay. So basically, the session ID is of two types. First is a non-zero number, and second is a zero value. For instance, if the session ID is a zero value, it simply means that the client is initiating the message for the very first time. The client wants to communicate with that server for the very first time. But at some point of time, it may happen that the client already has a connection with the server and it wants to update the parameters of the existing connection. At such instance, the client is going to use a non-zero number as a session ID. Clear? Any non-zero number. Okay. But if it is a zero number, if it is basically a zero value, it simply means that the client is establishing or trying to establish the connection with the server for the very first time. But if it is a non-zero number, it simply indicates that there is already a session value present and the client is wanting to update the parameters of that session value. Clear with this? I'm going slow, I'm going step by step. Kindly understand this, then I can move ahead. If you have got the understanding of this, we can move ahead with the fourth parameter. Kindly let me know about that. We are just in the first phase only. Okay, the first phase itself consists of so many things. First phase, last thing, that is cipher suit. Now, as discussed earlier, I may be having a different cipher suit. The server may be having a different cipher suit. So what exactly happens is the client will send a list of encryption algorithms, which is basically supported by the client, right? In this particular case, in this cipher suit, the client will send a list of encryption algorithms which are being supported by the client. In response to this, this entire thing is known as the client hello. These four messages totally comprise the client hello. So basically, this entire client hello, the small block over here, comprises of all these four values over here, which is nothing but client hello. Samjha, so it is very vast. It looks a simple statement, simple line on top of the arrow, but it's a huge thing when we go in depth. This is what we call as the client hello. Now, in response to it, as you can see, there is a server hello also. Okay, so let me give the attendance link. In between, we can complete this topic. Okay, I've dropped in the attendance link. Kindly fill it up. Okay, so let's talk about this server hello. We'll finish the phase one today and then move ahead. The server hello also consists of all these four parameters only, that is version, followed by random data, then session ID, and cipher suit. But there is some difference over here. What is the difference? Let me know. Oh, sorry, let me tell you. The first thing is the version. Can you elaborate the version field over here in client hello? क्या बोला था मैंने client hello में क्या use होता है? What is being used in client hello? Kindly let me know about it. Over here, what is being used in this version field? Any idea? What is being used in the version field of client hello? Then we can move ahead with server hello.
बेसिकली एसएसएल का वर्जन है सर, वर्जन 3 मतलब वो वाला.
हाँ, क्या बोला था लेकिन मैंने हाईएस्ट होता है, लोएस्ट होता है, क्या होता है?
Highest.
Correct. The highest SSL version supported by the client. Let me write it, otherwise भूल जाओगे exam के time पे. If you are taking screenshots, snapshots, kindly take it now. Okay. Highest version of SSL being supported by the client. On the other hand, over here in server hello, the server will tell the lowest version which it supports. This is the difference. Okay. For example, the client may support version 3 and the server may support version 2. Okay. So in such a case, both have to come to the common grounds that version 2 is common. We can move ahead with the version 2, right? So that is what exactly opposite happens in server hello. Similarly, random numbers. Again, the same fashion. Again, a nonce is being generated. 32-bit timestamp is generated. A 28-byte random number is generated, but this is completely independent of the client's random data. You're getting what I'm trying to say? The random data generated at the server's side will be totally independent of whatever value is being generated at the client side. They don't have any relation in between. Clear with this? Last two things, which are session ID and cipher suit. What do you mean by session ID in this case? Any idea? Try to remember what I told you whenever I was discussing the session ID for the client. The session ID was of two types, non-zero and zero. What is the difference? Can anyone let me know?
Zero
Just now,
मतलब
Because zero means a new.
huh. Zero
so
means new, correct.
yes. And non-zero means the client is already authenticated with the server and वापस वो update करने के लिए उसको initiate कर रहा है request.
Okay, तो अभी वही चीज सर्वर साइड पे सोचो. I'm just giving a scenario. If the client field, मतलब basically if the session ID was non-zero, then server क्या भेजना चाहिए? Over here in session ID. If the
बेटा
client session ID अगर non-zero था, तो अभी क्या भेजना चाहिए सर्वर? तो अभी सर्वर का सेशन आईडी क्या होना चाहिए अगर क्लाइंट का नॉन जीरो सेशन आईडी था तो? बहुत सिंपल क्वेश्चन पूछा है मैंने, बट ट्रिकी है थोड़ा.
उल्टा होगा सर.
नहीं, इफ द क्लाइंट हैज सेंट अ नॉन जीरो वैल्यू, मतलब ऑलरेडी सेशन क्रिएटेड है, राइट? यस और नो?
Yes.
So the server will send back the same session ID back to the client, just to
Okay.
indicate that we are continuing with the same session. Clear? Otherwise, अगर client ने zero value भेजा होगा, then server will create a new session ID and send it back to the client. Means now we are starting with a new session. This is the main difference. If the client is using a non-zero value, then server will send back the same value as it is. But if the client is using a zero value, then the server will generate a new value and send it back to the client. Clear with this? Yes. Last topic, that is cipher suit. Client की side से क्या हुआ था? Client had sent an entire list of cipher suits available to the server. Now what the server will do is, server will select any one of the algorithms from that entire list and let the client know that I am selecting this particular algorithm. For example, if I am selecting AES, then server will let the client know that भाई आपने 4-5 ciphers का list भेजा था, उसमें से I am selecting AES and now you can use AES. Clear with this? So based on the client's request, the server reciprocates accordingly. This is what happens in the phase one. I know this was pretty much intense of a topic, so you need to practice a lot. This is just only about the phase one we are talking right now. We have to complete this entire thing, phase two, phase three, phase four, and then move on towards SSL record protocol in the next lecture. So I hope this was clear enough.